one more thing to do today in my day of treasures. We didn't even answer this question. Did you answer that question? One time when I had braces, I lost my retainer in the lunchroom one time and I got thrown out. I lost it at like an away basketball game one time. I lost my retainer quite a bit. Anybody in here lose their retainer ever yet? Yeah. It's easy to lose because whatever. Just one more thing to keep track. Okay. Anywho, let's get Desmos out and let's set it up for polar mode. So we put that on. So the setup for polar mode is pretty simple. We are going to type in our function. And yesterday, do you remember what I said, how you could put in theta? You literally can type in the word theta and it will show up. Okay. All right, so for our curve, we're going to do our defaults to radians unless you switched it. I'm going to make theta be one turn around, and I'm going to make this be, well, first of all, I'm going to show you what happens if I make it pi halves, okay? Do you see it doesn't graph the whole thing? Okay, if I make it pi, I think it graphs the whole thing. If I make it 2 pi, then what happened is it just retraced the things. It's just possible that when you're doing polar mode, it retraces based on the angle of rotation. So that looks like kind of a flower, right? This one's called a rose curve. Okay. So let's talk about what kind of symmetry this looks like it has. Let's do this too. Do you see the grid? Click on the grid, please. We're going to switch to polar mode. Polar mode is the one with the circle that looks like this. So go ahead and switch it to polar mode. That way we can actually see the degrees. All right, are you with me? You getting that to show up? Don't feel shy about asking a question if you're not seeing the window, because I know we've never done this. What's up? You put what? Can you make it go back to 2 pi? When we do the Archimedes spiral, that's going to be fun, because the Archimedes spiral just keeps going round and round. Okay, so this particular graph, I'll show you the test for symmetry, and you guys are not going to make is there a line that basically you could reflect over and say the exact thing, and what you see is the y-axis, right? If I flip this over the y-axis, wouldn't that graph look exactly the same? So this is then y-axis symmetry. So if I asked you what the symmetry looked like, it actually for rose curves, you can tell from the equation. I'll get that in a second. Let's just sketch what we see. This back up. I'm going to just transfer this graph to my paper. So if those are, I call this a rose curve. If those are petals, on the rose curve, how far out does it look like the petals go from 0, 0? Yeah. So we would say then the length of the petal is 4, and do you see, that's kind of a graph of it. And what that means is, if I took the distance from here to the outside of any petal, that distance is 4 units away. Okay. How are you doing? And then also we would say this has y-axis symmetry. Okay. There is a test for y-axis symmetry, so I'll just show you or walk you through what it is. basically what happens if you would replace y with or r with negative r and negative theta, you could get back to the original, and that works here because sine is an odd function. So, but I'll save that for when you do polar equations later on in your life, which is not going to be in this class, and it won't even be in Calc AB. It would be in Calc 2 if you're going to be like an engineer, math major. Anybody in here going to be those things? Yeah. So then you're going to take Calc 2 and you're going to take Calc 3, so you'll see polar equations again there. But for us, I think that's good enough that we can just see what kind of symmetry it has. Okay. This particular curve is actually called a rose curve, okay? And so does it make sense? It looks like a flower. You know what a rose is a flower, yes? So rose curves are always going to look like this. And so even though I have a graph of my rose curve, I actually can model or tell things about the rose curve using this sheet. And you're going to always be allowed to use this sheet, okay? So I am going to just do a little analyzing of this rose curve. Where we are together. And I'm going to just follow the things that are on this handy dandy sheet. If I asked you for the domain of this rose curve, it's hard to see because domain's input and theta is this. And so it's not like before where I could see it on the x-axis. So, but the domain is all real numbers because you can put anything you want in for theta. So if I asked you to find the domain of any rose curve, you're going to just reference this. It's going to be all real numbers. All right, what if I asked for the range of this rose curve? We're talking about the specific answer. Again, that's hard to spot, so I'm going to just use this sheet. It says it's negative a to a. What in my equation, we have a sign one, right? A is just the number in front here. So what's a? A is 4, so the range would just be negative 4 to 4. This is a continuous function. We're just analyzing it. So if I ever ask you to analyze, which I will. So this is continuous. That just means there's no breaks. I could draw this without picking up my pencil. And then symmetry. Okay, we already decided what kind of symmetry does this have. Y-axis, okay? But here's a little cheat for symmetry. That let's say you didn't have access to the graph, then you could use this. It says if n is even, let me point out where n is. N is the number in front of theta. So in our case, what's n? Yeah, so n is 5 here. Is 5 an even or odd number? It's an odd number. So if n is odd, okay, so it's not this top one. If n is odd, then I have a choice. Was this a cosine or a sine? It was sine, so it says it's symmetric about the y-axis. We knew that already, right? But this will tell us based on the curve what it is. So this has y-axis symmetry. And then this is a bounded function. It's got an R max. An R max means this max value here. What's the furthest it gets away from the middle? And you guys already told me the R max was 4, but you can always get by it's the number in front of the function. The R max is just 4 here. There's no asymptotes. And how many petals does it have? 5. Okay. But there's a code for this too. If n is odd, it's the same number. So did you see the number 5 was in the equation? So when that's an odd number, it's the same. So 5 here, 5 petals. What does it say when n is even? It's double. So when n's even, it's going to be a double function. All right, would you guys hop over to decimals a minute? This one has 5 petals. And let's change n to an even number and see what happens. What do you guys want to change this to? Kale, give me an even number. Oh, 56. 6. Okay. How many petals does it have now? Without counting them, how many does it have? Nope. You haven't been paying attention. Look at your little sheet. 12. When it's even, it's double. So that has 12 petals. All right. So that's rose curve. Okay. The second curve, we're going to do all sorts of them, but we're just doing 2 today. So here's a rose curve and an example. We're going to now do a limacon. And a limacon is a French word, apparently Old French, that means snail. I think of it as a bean. Like, have you ever seen a kidney bean? Like, pencil makes sense with beans in it? Any kind of bean has like kind of an odd oval-ish shape, but it's kind of curved a little bit. And that's what limacons remind me of. Okay, so you could think of it as a lima bean, which is the worst bean in the history of beans. Have you ever tried one? Don't. It's going to make you puke. I love beans, but lima beans are gross. They're like mealy, and you like them? Maybe it's just I have had a bad childhood experience. We'll save that story for another day. Okay. Let's do a limacon curve, and I'm going to show you what is different about this. For our second example today, we are going to graph r equals 3 minus 3 sine of theta. So there are actually 4 types of limacon curves. We're gonna put them in on our little handy note sheet in a second. But for now, let's see what this looks like when I graph it. Okay, so this is actually called a cardioid limacon curve. Okay, so cardioid limacon curve has something that looks like a heart shape to it. Okay, so there are 3 other types of limacons that we're going to write down. So actually, to have you between the two of you grab a textbook off the shelf and open to page 490, please.